In this video, I will explain problem number 7 from exam 2. In this problem, we have a triangular solid, and we want to figure out magnetic flux through the ramp face. So first, we're going to look at this picture that I drew here, and we know that the flux through the entire thing is going to be equal to 0 because it's a closed surface. We know that from Gauss's law, which states that the integral b dot dA is equal to 0 on a closed surface, once again. So first I'm going to look at the flux into this through the ramp face, not through the ramp face, through this rectangular side. And first, that is just equal to, so we'll call it flux in is equal to B times the area of this rectangle. So this is going to be equal to B times 10 times 3, which is going to be equal to, and B is just equal to 1, so we have 30. But the important part here, looking at the answers to this question, we have to figure out, we know that the magnitude looks pretty even, that the magnitude is it's more a question of sign and magnitude than just magnitude. So for the sign is going to be very important. So we know that since, using the convention here, we know that the flux out of a surface is defined as positive and the flux into a surface is defined as negative. So we're going to define this as negative since it's the flux in. Okay? And then we know through Gauss's law that the flux in plus the flux out, the other side, should be equal to 0. So we know that the flux out should be equal to positive 30. By convention, that makes sense as well because this is coming out of the ramp phase, which is defined as positive.